All right. Good morning, good afternoon, good evening, everyone. Welcome to Hollywood Props with ultra-fast desktop 3D printing technology, hosted by Nexa 3D. And I will be your host. My name is Michael Curry, and I'll introduce our speaker in just a second. We're going to just hold on the line for about a minute or so, wait for the folks we had a lot of registrants, so we want to wait a little bit of time, make sure everyone gets a chance to get settled in. And get ready for a very fantastic and informational and exhilarating webinar from Rob, who I'll introduce in just a few minutes. So stand by for 1 or 2 more minutes, everyone. Thanks. A little bit of housekeeping while we're waiting for folks to jump on. There is a Q&A section down at the bottom of your screen. You can click on the Q&A button and you can enter your questions there. We have some folks in the studio who are going to be monitoring those questions, and so as they come in, I'll try my best to get to them in line during the presentation or afterward. So just hit that Q&A button and ask your questions there. All right, so we'll just give it 1 more minute and then we'll kick this off. Okay, so let's get started. So we're going to present today how prop making is done with 3D printers, Hollywood, Bollywood, TV shows. You're seeing various types of shows being created every day. Content is king these days. And so we want to tell everyone how you can create props with ultra-fast desktop 3D printing technology. We're sponsored by Nexa 3D, and we're actually inaugurating this webinar on the same day as our shipping announcement of our new Zip product line. And that brings me to who I am. So my name is Michael Curry. I'm the VP of our new desktop printer line. And so we've just announced the Zip, and we're shipping the Zip, and I'll talk about that more later. And I'll be the moderator for today's discussion. And our featured panelist or speaker is Rob Wiggins. He's a professional Hollywood prop designer. He'll get into his background, but he's worked as a model maker at Hasbro. He's worked on major movie franchises such as the Transformer franchises, worked on props for Lucasfilms. He also has worked a lot within 3D printing OEMs. So he's been the internal creative director at Formlabs. He's also our internal creative director here at Nexa 3D now. And all that started because I asked Rob to come be our first beta tester of the Zip. And he loved it so much that he wanted to make it a full-time gig. So with no further ado, I will almost pass the baton to Rob. I just want to say a few things about Nexa 3D first. So we are a 5 years young 3D printing company. We are in the polymer space, and our main mission is digitizing supply chain sustainably. And how we view that is that we want to bring you 3D printing tools that will allow you to produce parts at volumes to be able to sustainably make your supply chains work. We also want to spend a lot of time making sure that the products we give you are also sustainably created and designed and sourced. And so that is really our mantra, and that's kind of why we exist and how we're different from many other companies. We have a lineup that is both industrial and also now desktop. So if you're looking to scale your technology from, say, prototyping all the way through production, Nexa 3D gives you one cohesive set of tools, or coherent set of tools to do that. And I will now let Rob get into the meat of the talk. And sorry, before that, we have a poll. The folks in the studio reminded me of the poll. So let's take a quick moment and ask which best describe you. 1, I'm interested in getting my first 3D printer. 2, I already have a 3D printer but could use an upgrade or an addition. 3, I already have all the 3D printers I need. I don't think anybody's going to answer that question. And 4, I'm just curious about 3D printing tech, but don't have an application for it. All right, so we'll just give that poll a few seconds to breathe. And if you guys don't mind just chiming in with your choice, I'm going to choose number 2. I already have it. It doesn't let me actually vote as a panelist. So there you go.
Yeah, I wanted to vote too, Mike.
Okay, This is the results. So most folks out there already have a 3D printer. There's some new folks as well. Surprisingly, some people have all the printers they need, and some folks are just curious. But so we do have folks that are coming to this with 3D printers, but always looking for new technology. So that's great to hear. All right, so I will pass it over to Rob. Rob, take it away.
Hey everybody. If you're new to who I am, I guess I should go over that really quickly. I'm an artist first, concept designer, sculptor, prop maker, product designer. There's a whole bunch of stuff. But I've created a bunch of things. I worked with Hasbro, toy company, for about 11 years doing concept work for them, for film, for TV, for toys. Worked 2.5 years at another 3D printing company, and dabbled in design, but started my own props business after that, and worked on Transformers films, as well as currently developing props for design, TV, film as well, while they're at Nexted now too. So that's been a blast. But kind of to kick things off, I see that photo there with Gordon Tarpley. If you're in the props industry, everybody knows that guy. He's amazing. But just, it's interesting, as an acquaintance of mine probably best said it, 3D printing is being used in Hollywood, in the industry, so to speak, for world building. So you're probably thinking, well, what is world building? Well, just if you look at the slide there, that's kind of encompasses a lot of the stuff actually that I've done and that I do. Some of the stuff like the bee there that you see on screen, and then behind me, this guy's like almost 30 inches tall. This kind of encompasses everything that 3D printing is being used in Hollywood for. So we're going to go through kind of, each point of that. But most likely when you think about 3D printing being used in Hollywood, I'm sure a lot of you are probably thinking props, of course. The biggest thing is probably like right there, as you see on screen, blasters, lightsabers, things like that. And traditionally, you'd be right. We got that. You've got spaceships, ray guns, you name it. But the truth is, everyday items are also 3D printed, and it just depends on the production needs. Just to give you a little story, I helped in printing things like pagers, phones, walkie-talkies, or just common household items. And it could be for so many different reasons. So it could be that the prop or the asset that you're printing is maybe it's unavailable, or it's just hard to source locally wherever the production is. Or it could be like an actor or producer, they might not be comfortable performing with a real asset. I mean, just recently, there was a big uproar about just having firearms and things like that. So you could be 3D printing a whole bunch of things. But one of the other things that was, I guess, stands out to me in that arena of kind of like everyday things was one time printing out a walkie-talkie for a paramedic prop, because interestingly enough, printing out this walkie-talkie that was going to be used for the paramed in the TV show, it would be lighter actually than the genuine like Motorola device. And surprisingly, it was more cost effective too, because just kind of printing out the hero side, you'll hear me say that a lot, the hero side, it's kind of like basically whatever's camera facing is going to be called the hero side, or like a hero asset if it's going to get into the really nitty gritty details. But it was more cost effective to just print that than to buy another Motorola device, which is weird. But that's the kind of thing that happens sometimes. But other than that, I mean, 3D printing is in the entire ecosystem. As you see here, even with miniatures. This is from Leica. The director here from Leica was actually also the director for the Bumblebee film. But, they're using miniatures like this when they're doing like kind of stop motion animation. That's maybe where you think about it in general. But honestly, this has been used ever since, the 70s. If you think about Star Wars, the Death Star trench, you think about like the laser turrets that go along the trench, all of that stuff is miniature work. So miniatures have, you know, they've been used in film and TV for a long, long time. Even when you think about even Godzilla films and stuff like that, I think that's probably like a perfect example of using miniatures in the film industry for that. Now, next, practical effects. Again, going back, this is kind of tied in a little bit even with miniatures, going back to that Godzilla, um, Godzilla standard, I should say. But this is way more recent. This is the Razor Crest here pictured. And that was a practical effect because, Dave Filoni and Jon Favreau, they really, really were interested in having, going back kind of to like the old way of shooting things. So it just, it looks better than, sometimes doing it in 3D. Sometimes, textures can be weird or something like that. Sometimes just doesn't seem right sometimes. So sometimes it could be better to just 3D print like these practical assets that you're going to use and then have effect shots using that actual 3D printed model. And this thing right here, the Razor Crest, that was an amazing practical effect. This is an amazing model that they put together using 3D printing, resin 3D printing. So that was a great asset. And you see that a lot nowadays too. People are trying to get back into that. It just, it changes just the feeling, the heart of whatever it is that you're shooting.
Hey, Rob, just real quick on that. You mentioned resin 3D printing for that particular prop.
Yeah.
Are you seeing a particular technology dominate, or a particular mixture of technologies, 3D print technologies that you're seeing that are most prevalent in Hollywood?
It's definitely a mixture. People are it's just like anything, whether you're a plumber, or electrician, you're going to use whatever tool is the right tool for the job. So, sometimes that can be, FDM, that could be SLS, it could be SLA or MSLA printing. So you're just going to use basically what's going to be the right tool for the job. But looking at something like this asset here, like the Razor Crest, if you've seen the show too, that they've got these really great detailed up close shots, when they're doing the flybys and stuff like that, when they're dogfighting and things like that. So I think that kind of lends itself for something like this to resin printing, even if the actual maybe like the inner workings of the 3D print, maybe if they used aluminum or FDM or just a combination of different things. The outside, the hero side of it, when you're getting those shots, is most likely going to be resin printing, just because it's going to be a lot less of a post process on a resin print than you'd have on something, say like FDM, where it's you're going to be sanding for days to kind of get the surface quality that you want on something super detailed like that. And as you can see, that thing's got a ton of detail, so it's just easier.
And then this is my follow-up question on that is, miniatures are small, some of the props are small. What is the biggest thing you've seen or 3D printed, or do you see large format 3D printers at studios?
Absolutely. Like, man, I'm trying to think the biggest. Man, maybe like even they used one of the studio printers at Paramount for a Comic-Con one time. There was a big when this guy Bumblebee, when that got released at Comic-Con, there was like a huge 3D print of Bumblebee there at Comic-Con at the Hasbro booth. And that was 3D printed. And when I say huge, I mean that thing was it was life size Bumblebee print.
Hey, Rob, were you showing something that your camera is off? Just want to make sure.
Oh. Sorry about that. My bad. Yeah. So I was saying this guy back here, Bumblebee, for Comic-Con, right when the Bumblebee movie was released, that they did a huge 3D print, a life-size 3D print of that Bumblebee. So I mean, if you stand next to it, I mean, I want to say he must have been like at least 20 feet tall.
Wow.
Yeah, but I mean, I'm sure that, it can get crazy with what you can 3D print nowadays.
Cool. Nice.
All right, so now we're on the virtual production side of things. Like typically, which started kind of back, for me anyway, in my opinion, started back in the 90s with George Lucas and doing the prequels, Star Wars prequels. He did a lot of green screen. So it was like actors who had like, basically are standing in like a huge green or blue room, and everything was just digitally produced, kind of post-production wise. So they're kind of like just acting to things that weren't anywhere, near them or could be changed later. So, I mean, that could be a little bit clunky and kind of hard for the actors to kind of, act to that. Not to mention the lighting too. Lighting is a huge obstacle, or its benefit, depending on how you look at it. But that can change a scene, and in post-process, it could get so expensive to try to, reproduce a shot if the lighting is off. So now with the virtual production, like I believe they have a stage like this in the UK. I know for sure they have one here in Southern California. It's called the Volume. And basically what that is instead of using green screen or blue screen, it's basically LCD screens. Huge LCD screens that kind of surround the entire area. And something like this, with these photos, this was used for the latest Batman film. So they use this. It's great because you get the correct lighting. You get these backgrounds and this kind of scenery where the actors can really react realistically or more realistically with the scene that they're in. And they've even got it down to a science where when the camera is angled at the actor, digitally, they can manipulate where they are in the scene so that it always looks correct, even if they're moving. So it's just a really fascinating technology. But a lot of times 3D printing can be used even when you're doing something like this in just about anything, from props to even making or engineering tools that could be used behind the scenes in virtual production. So our next slide here is pitch work. And this is my forte. This is where, I've done a lot of stuff for a lot of different companies and just doing pitch work. Just an example of kind of the thing that I have here were just some helmets that we were pitching to get into a TV show. And really it's just so powerful having, 3D printing available to us right now, just because something like that typically you could pitch to a producer or to a director, and it's hard for people to kind of envision what that project is going to be. So having something tangible, having something physically there in front of you is very powerful, and it holds a lot of weight when you're trying to get something funded. With Hasbro, man, we did a ton where we would just do kind of 3D printed maquettes or things like this huge bumblebee behind me. It's one thing, and if you're presenting it on paper or if you're just showing like maybe concept art, hey, this is what the asset's going to look like in the film, and trying to make that seem cool, as to just bring in like a big, 2.5 foot tall beast right there in front of the producer or director, and then being like, okay, I like that, and then we'll fund that, So that's been a huge boom in the industry. So the prop making process. Okay, this is where the fun begins, you guys. Typically, a lot of times you'd start off with sketch work, just making concepts of what you want to make a prop of, or sometimes if you're working with like an art department, they'll send you, hey, this is what the final prop needs to look like. So this right here, in fact, this is one of the sketches that I've done that this was actually for like an art contest way back. I mean, I think this might have been like a decade ago even. But that was, goes from sketch, you go right here to the 3D designed asset. I believe this was done in Autodesk Soft Image. And then you have something like this, where you're just going to do what's called a turn. And it's basically just orthographic views of the 3D model that you make. Sometimes you can have a little bit of dramatic lighting, or put them in a situation or something like that that's kind of going to sell the importance of, whatever it is, whether, be a prop or just the entire character design itself. So that's kind of just like a concept page that,
so,
you typically would see.
Just out of curiosity for that one, was this like an original character you developed, or is this something that they gave you a character and then you flushed out how they look?
This was a video game called Mass Effect, and the art contest was something like realizing, I think it was like either making a new character or kind of like doing the 3D design of like one of the characters in the game or something like that. So this was my take on one of the characters in that game. So they had, as a video game, it's already released. So they have some characters, but for this particular character, she was always had her helmet on. So you never got to see what she looked like physically. So this was my interpretation of what the character would look like basically under the mask and with a new set of armor and everything. So the whole thing is actually, like my original design, but of course it was, just for fun, but gonna kind of, also, for that art contest that I entered a while back.
Cool.
But going on to this next slide, that's kind of what I wanted to explain is I don't even do sketching anymore. I just go straight into 3D modeling. There's so many tools out there. Like Blender's a really good one, where you can just kind of go right into the 3D program of your choice and start. You can even digitally sketch nowadays, right into the 3D program. So I don't even put, pencil to paper or pen to screen nowadays for stuff like that. Getting into preparation after you've got your 3D design locked in, and of course you're ready to print. This is a photo here of Nexa X software. So this is the 3D printing software specifically for Nexa printers. Like you see here behind me, the zip. Man, this has been fantastic in just kind of getting things together before you go to printing. So something like this is going to slice it and show you the volumes and all that stuff and help you to get the print made. Okay, it looks like we got a walkthrough too of just the Nexa printers. This is the NXC. I believe that's the 400, isn't it, Mike?
Yeah, this is the Zip's older and bigger brother, the NXE 400.
Yeah.
While this is printing out, there was a question in the chat actually.
Yeah.
About what kind of degrees do people typically get, or what kind of training do they have to create models, et cetera, industrial design, and what do you have?
Yeah. I mean, with stuff like this, I wouldn't say like you need a specific degree. I think experience is probably going to be like the biggest benefit nowadays. I mean, you could debate over that as much as you want. I mean, like nowadays, I guess that stands probably for almost any industry nowadays. I feel like experience is probably valued a lot higher. But as far as degree, I I know for me, like I went to school for computer animation. So that's, that's how I got started with like, 3D modeling and the programs and things like that I know. But to be honest, I think the best information or education that I got was just doing research. You've got so many things out there now, like with YouTube, it's just so much information out there. It's so easy to get good, as they say, with what's, available to everybody.
Okay, hey Rob, so this next section, we've had a number of questions on post-processing and what does it take to get that final part. So it looks like we're in the very important and also sought after piece of information here.
Okay. Wow. Okay. So yeah. So just to give a quick overview of like what we have here on screen, you've got the model, you've gone to 3D print. Now there's a little box down there that says test, which is great because you're not just going to pop these things out. Even if you do all of the calculations beforehand and measuring, sometimes you 3D print something and you might forget something, or just something just doesn't work as expected. So then you have to go back to the drawing board, so to speak, and reprint. So, there's a lot of, trial and error, a lot of fail fast. So when you have something fast to print with, that's a super benefit. Now getting kind of into the post processing of, once you have your print, of course, there's support removal as shown on screen, there's sanding, then there's priming and painting. Man, sanding, I think is probably going to be the craziest part because there's support removal, there's sanding, there's priming and painting, then there's sanding again. And then priming again sometimes and painting. So sanding is a big part of it, but it depends on the kind of surface that you're trying to get.
Hey Rob, what's the usual number or iterations of priming and painting you would do for a finished part? What's the extreme, like the norms and the extremes on those steps?
Okay, well, let's see. For something like this is from the Nexerator project. You see how shiny this looks and how chrome this is, right? Typically, if I was, doing something like this, in order to get chrome, or in order to get something look like chrome, this kind of shininess, you're going to be sanding a while. You're going to have to sand it. You're going to probably have to wet sand. You're going to prime it, and then you're going to wet sand again. To get this result is a result of how much you're sanding. But, to Nex's, benefit, this part right here, the inside, I didn't sand at all. I just painted this. So that kind of, I think it speaks to just the quality of the print. This is like, I mean, kind of unheard of to just pull this out of the printer, wash it, basically prime it. And then I put a gloss, paint over on it. But after that, I just put the metal paint that I use. It's called Alumiluster. It's from Imperial Surface. And then these are the results. Now this side here of the print, where it's kind of got like a matte finish to it, even this is super smooth. And this is because, I did sand this side because I wanted this to kind of look, like, just kind of like a matte slick finish, almost like a Batman armor or something like that. So again, it's just kind of, it's elbow grease, it depends on what the surface is going to be.
Cool. Well, while we're here, we have another question on painting.
Sure.
And is there certain paint that adheres better than others, or does that even matter?
It does. It's funny, like I talked about this a lot with a couple of guys like there's a primer that I use and I've tried like even expensive primers, but I keep going back to just the plain stuff you get at Home Depot, just like Rust-Oleum primer. It's been really great. Now, what paint that you use on top of that, that can have an effect depending even where you live. Like I used to live, back east in Providence, Rhode Island, and even in Pawtucket, Rhode Island, because that's where I was back when I was, working in the office at Hasbro. But because the temperature out there and the climate out there is like a little bit more humid, it's very difficult sometimes for certain paints to adhere to the surface. Where out here in Southern California, because it's dry weather and it's warm most of the time, I have no problem with any paint. But it honestly, it really does depend on what look you're going for. I would say do some research because there's probably not enough time to even get into it right now about the different types of paint. Like you see there in my photo, I've got paint on both sides. On one side is kind of more of my acrylic water-based paints or acrylic-based paints. And then on the other side is our paints that are more kind of chemical-based. I'm trying to figure out the actual makeup of this stuff. Honestly, it just really depends.
Sometimes a lot of hard questions comes down to it depends.
Yeah, I know, right? I'm sorry, man. I know it's probably not the answer you're looking for, but yeah, it's one of those things. It just depends. Because I can tell you one thing, and then it's like, hey, that's not working for my climate, So I'd say, yeah, just research, research it. You're probably just to add on, maybe, okay, I'll tell you this. You might have a little bit tougher time using acrylics than you would any other type. But conversely, with acrylic paints, you have more choices as far as the different type of colors and stuff that you can make yourself to use than you would with paints based on other solvents. So again, depends.
Cool. Thanks, Rob.
Okay, so yes, this is what we'll get into. Just a quick story. This was this print here. I did this, man, this project was about 6 weeks total. It has an interior on it. So it's not just a bucket. Like a lot of times when you're, on say like a, film or TV, this might be broken down into 3 different assets. You'll have an asset that's, for close-up shots, like your hero asset. Other times you'll have another asset that'll have just the interior, maybe for hero shots. And then you'll have one that's kind of for stunt shots. So you're making about, 3 different assets. So this one was kind of an all-in-one because we didn't know if this was gonna get in, because this is actually a pitch that we did. And it just didn't make it into the Obi-Wan show. They were like, it almost made it onto the Obi-Wan show, but I see why it didn't now, because some of the elements of the TV show. But something like this, going through the different phases, you're gonna have a certain amount of time for design, a certain amount of time for print. For this took about 4 weeks to print. And that's just with using, like you could see there in that slide, those are some of the printers that I had in the past. They're both MSLA printers. The one on the left there has a 4K monochromatic screen. So it was, before, for me, it's like, that's pretty fast, because it was, monochromatic screen. The resins that to get for those, they're low cost. But even with that, you kind of have to shop around for resins that are going to work for you. The good thing is with both of those printers, they're both open platform, so as long as you get a resin that's in the 405 wavelength, you should be good. But then you've got to do stuff like, mixing some of the materials, because the thing you don't want is to go through all of this design process and making sure, you know, all the engineering works on it, printing it out again if there's any, you know, flaws or anything that needs to be adjusted. And then you drop it and it just breaks. You know, if you drop it just from like, you know, a couple of feet and then it just breaks in half. So a lot of times I was doing like kind of a mixture of two different resins, a fast resin and also what was called tenacious resin. I did like a 50-50 mix of that so that they would be a little bit more durable and just kind of handling. But with anything, you know, with these printers in particular, it's kind of like you experiment. That's why I said experience is probably going to be a lot better than even having a quote unquote degree in something, because you can do all of the, you know, pre-thinking you want and, you know, coming up with something, you know, to print and, you know, trying to figure out things. Even on the 3D side, there's so many programs that'll help you with, you know, the engineering and things like that. But once you print the thing out and you get to touch it and see it for yourself, that's when you're really going to know. But like I said, it was a long project, you know, just as it stated there, it was like 3 months total. But yeah, the print time on something like that with those old printers was about 4 weeks, because you've got, you know, even with that larger format printer you see there to the right, if I'm printing out a part, like say here, I have.
And Rob, to just be clear, it's not, you're not printing the whole thing in one shot and it takes 4 weeks. You're doing something else, right?
Yeah, yeah. It's printed out piece by piece, you know. I mean, something like this, see how just the size of this would take about 32 hours on that MSLA printer there. So now skipping to the next serrated helmet project, it was a dream, man. It was like a dream come true. I mean, having something like I just showed you before, going from something like this and taking 32 hours or something like this, I could print this on an Nexa machine within 5 to 6 hours, or sometimes faster, just depending on what material you're using. But the material that I particularly like to use, this would probably take about 6 hours to print. So it's just been amazing. But here I've got Nexa Raider back here. You can kind of see how big this print is. Now, this project that we had here with Nexa Raider, this took about 4.5 weeks. So in 4.5 weeks, about 2 weeks was spent on designing and engineering it. And we printed this whole thing out over the weekend. Over a 72-hour printed period, we printed out this entire helmet, which is just unheard of. It's just remarkable that we'd be able to do something like that. And honestly, that's why it was so exciting for me, and I couldn't turn down the opportunity to work with Nexa with something like that, being able to do something like that. So
I was going to make a pitch work joke there, but this was a commissioned. We commissioned you, not a pitch. So
yeah,
thanks, Rob. The project came out pretty awesome. So
yeah,
we have some fan questions here. We're curious if the Iron Man helmet is a 3D printed helmet.
The Iron Man helmet?
Yes.
I don't see why it wouldn't be. I mean, I've seen props of it, but you know, I didn't work on Iron Man, so I can't tell you for sure. But I mean, come on, I don't think there's any way that it's not 3D printed.
Oh, all right.
So, just speaking. Oh, did you guys want to talk a little bit about the materials you used?
Yeah, well, let's maybe just hit some of these questions. I think
Okay.
because one of the questions was, this is sort of a controversial question, maybe, or one camp here, one camp there. When
Yeah.
you're working with resin printers, do you prefer alcohol, water washable resins, or some other solvent that you prefer to work in?
Um, Again, I feel like this kind of like a tools thing, you know? So it's like whatever tool is best.
Okay, maybe
Um,
when would you use alcohol? When would you use water?
that's kind of dependent too on the resin. Like I've tried using water a couple of times, but I don't think it's for me, it hasn't worked as effectively as with, IPA, just using a little bit of isopropyl alcohol to get the resin off of the part. There are other materials that you can use. Like I know I've even dabbled with the stuff that Nexa has, which is the X Clean, which has been really good as far as getting resin off of your print. Um, and it's easily accessible. At least I know where I can buy it. I've heard of people using like even TPM to kind of get resin off of their part, but it's kind of like, where do you find that? So, um, but I feel like IPA has been like the thing to use, and a lot of people, myself included, are using ways to kind of even recycle the IPA that we do use, so that it's not so much waste created.
Yeah, cool. Some questions on the business side. So one person wanted to know, what kind of financial investment does it take to get off the ground with a business like yours? Another
Mhm.
person wanted to know, what's the hit rate? How many pitches do you do, or how many props do you do before, it's accepted? So kind of give us a little bit of more of
Yeah,
the dynamics of the business side of prop making.
it's kind of like I mean, even before I started my business, I already had projects. So it's hard for me to say like, okay, it takes X amount of dollars to get a business like this started. I mean, of course, you need the actual tools, you know. But for me, I already kind of had a heads up on that, just because I was already working on different projects for different companies. So before I started, off on my own and kind of created my own, just prop making business. But a lot of it is kind of, before you even step out to do something like that, is definitely networking. Um, I know for me, like even how I started with Hasbro is my friend took me to like one of these, like, it's not Comic-Con. It used to be a convention called BotCon. So it was one that was specifically for like Transformers fans. And I had like no idea the thing even existed, but like one of my like good friends from New York, he got me. He was like, "Man, we got to go to this thing called BotCon." I was like, "Okay," and I just went with him. And they had an art contest. So I entered the art contest, and it turned out that the guys who were judging the art contest were people who worked um, at Hasbro. And once they saw my stuff and they were like, "Hey, would you like to work on like Transformers film coming out?" And I was like, "Yeah." So that's how I got in with them. And once you start doing jobs, gigs, people, word gets around. They're kind of like, "Hey, man, this guy can do this guy can do that." And before you know it, you'll have more business than you can really take. You probably have to turn people down. But having that as kind of your base, once you've got like all these projects going, you wind up having to get the tools that you need to complete those jobs. So that's how at least it started for me.
Gotcha. All right, let's advance, and I think there's some technique questions we'll get to in the Q&A, just to
Okay.
make sure we get through all the content.
Great.
Okay, so this is back to me. So we go to the next slide, please. So thinking about vat polymerization, that's what Nexa 3D has been focused on. We think of three different generations, and if you can drop the three slides down. So there's SLA, which started in the 80s. This is the version that 3D Systems came up with, chuck hole, later inverted and brought to the desktop. And then the next generation was moving that to a DLP process, where you're flashing the entire layer all at once versus using a laser to raster out your part, your layer. And then the third generation, which Rob talked about is masked stereolithography, where you're using LCD screens to mask the light, usually a full bath of light that is hitting the back of the LCD and then being masked to create your layer. We are Nexa 3D is in that third generation, and our particular flavor of that is called the lubricant sublayer photo curing process. So let's go to the next slide. So real, just kind of quick pictorial view of the world. You have your inverted SLA on the one side where you're rastering out your parts, and then you have your third generation on the right, and you're flooding the printer curing plane all at once, and that gives you your dramatic speed up. So there's some pros and cons here, but really one of the greatest things is that this version is more uniform and then faster. And in theory, your LCD is what defines your pixel, and because the LCD is a fixed plane of pixels, alignment anywhere between any pixel on the LCD and another pixel is fixed in place. So you have the chance of creating very high accuracy prints with this technology. And for Nexa 3D's version, so we've taken that, you've seen MSLA in low-end printers all the way up into high-end printers. And so we started really refining this process at the high end, and we call that our LSBC technology. And that is really about doing a lot of systems engineering to make sure that the LED arrays, the lensing arrays, the imaging masks, and most importantly, your membrane technology are all working in concert. So with that, we've been able to create a stack of an MSLA stack that is very high performing. And give you an idea of some timing, we can go 7 times faster than a typical SLA light engine stack. And one of the cool things, next slide, please. You can drop down all the images. Our membrane, just one of the reasons why this particular version can go very quickly is our membranes have dual-sided non-stick coatings. So as you start to peel away your model, you initiate almost like a peeling tape or removing a Band-Aid approach, where you're breaking the bonds between the membrane and the part one by one as you slowly progress the peel across the part. So that gives you really great detail, gives you great speed, and that's part of that technology stack that we mentioned. Next slide. And on LCDs, for a while, people had talked about, you're working in a digital space, but the reality is, even though you're working in a digital space, it's truly actually an image processing space. So with LCDs and even DLP2, you can do a lot of image processing techniques to either enhance sharp features or to create smoother features. So you really have the ability to kind of operate in a very sharp regime, where you're using image processing to create sharpness, or you can also use image processing to create more organic shapes, in this case, anti-aliasing for, I guess, this grenade that's sitting on Deadpool's belt. So that you're operating now in an image processing world, and there's a whole lot of techniques that are being developed to really create great surface quality and great fine detail. And the zip. So we've taken that industrial MSLA technology. We've recently took about last year and a half and developed this printer. We just shipped it out this week. So really excited to see how this goes and get this in people's hands. Next slide. Just to give you a quick idea, this is approximately a 4.8 liter build volume. It's a 4K monochrome screen, and it features that lubricated sublayer technology that we had. And this is a value. This is a big value, and we are selling the printer at $6,000, full package at $8,000. And next slide. We have a full workflow for you. So Rob talked about Nexa X. You have got the printer. We have a integrated washing and curing system, and then we have a finishing kit. So that's the whole workflow, and that's what you would be getting into, bringing our desktop printing solution into your workshops. And next slide. And then back to the Q&A. Let's just try to see if we have any other Q&As that we want to hit. Okay. There was a question here on the Nexarator, or maybe a helmet project in general. Is there approximately a cost estimate of something that large, kind of what you're in for from a resin perspective, I guess is the question.
Yeah. Say for any of these two, I'd say approximately about just under maybe 2 liters of resin. So you're looking at basically 2 liters of resin, whatever the cost is for the 2 liters of resin. That's what your cost is going to be, with the time that you spend on it being, I guess, the most expensive. So the faster you can get this thing to print, the more money you're going to save. That's for sure.
And then, so another fun one. Do you do anything for D&D? So I guess that means Dungeons and Dragons.
I did actually. But it was a long time, like a really long time ago. We had did some, so I don't know if I can talk about it because I know that I think they're doing like pre-production for some D&D films. So yeah, it was a while back, but yeah, but if you're thinking about more along the lines of doing miniatures and stuff like that for the actual game, yeah, this stuff is amazing for that. Actually, me and a friend we're putting together kind of like another role-playing game, not associated to D&D at all, but making like the little miniatures and stuff like that. Just the quality of the prints on this thing, like I said, like with that one part I showed you on the Nextrator, I didn't even have to really do any sanding just to get that chrome look to it. So these are great if you're going to be using them for miniatures like that.
I think you're capturing a following after this webinar. So someone wants to know, have you done anything for cosplay?
Oh that's my thing. That's my jam. Yeah, like we just came back from Star Wars Celebration, and me and a few friends actually did some cosplay stuff. So it was fun because it was like some guys from Lucasfilm who were like, yeah, dude, we'll do cosplay. So it came out really dope, actually. Yeah. So it's really great for that. And I actually at one of the previous companies I was at, I tried to pitch that to them to try to get them, with cosplay, but it just never happened. But I think it's perfect for that. If you look online, there's a lot of content out there, even on YouTube, and there's a lot of cosplayers who are using 3D printing. So you'll see for yourself. Yeah.
Question here, back to the Nextrator helmets. What's kind of the time budget between printing and finishing and painting? Or should I say printing, sanding, and finishing?
Yeah. Well, with Nextrator, we did that over the weekend. So I went in on Friday and just, I was there like back and forth, picking prints off of the printer and putting new ones back on over the weekend because we were slammed. We needed to get it done. And we did. So that's, it just, I guess it depends. Like, to give you an example, I think for Nextrator, it was about 80 different prints or 80 different parts over about 56 to 60 separate prints. So all of that was done within a 72-hour period. I wish I can give you maybe like the back-to-back times for each print, but I think the longest prints that we did with Nextrator came out with maybe about 9 hours. And that was for one huge print. But yeah, it went really fast. Now, I think what was the other part of that question that they mentioned? It was like,
so the ratio between printing and then post-processing,
okay,
so for every part, you're printing an hour, and then how much post-processing to get it to be its final version.
Right. So while it took 3 days to print this on the machines nonstop, I gave myself a week for priming and painting and all that stuff, which is crazy. I think for me, it's like, maybe because I've done it before. So, and, I know some guys, man, they can paint something up in, a few days. I think that lends itself more towards the depends, type of answer too, because it also is depending on, the climate where you're at, or if you've set up, like for myself, I have a paint station and I have heaters in there and I have a fan in there. So I'm able to keep it hot and dry so I can get the quickest turnaround when I'm painting and priming. But again, it depends on what type of finish that you're trying to go for. If you're doing anything that you want to look like metal, or if you need to clear coat it, if you're painting it like you would like an automobile or something like that, sometimes it takes a day or so for things to cure. Sometimes you can just bypass the thing curing and just get it to the point where it's dry enough that I can put the next layer on. So, but in regards to Nexterator, I gave myself a week to paint, prime, and process it. So it was, nonstop working basically.
All right, cool. I think that wraps up the questions. I saw some questions in the chat around, where can I get one of these things, availability, what have you. Just to answer that, generally speaking, in North America and Canada, you can buy from our partner network or from us directly. And outside of US and Canada, we're developing and grooming a set of partners. So it really kind of depends upon each country. And we are launching, starting today, a upgrade to zip campaign. So this gives you the ability to get up to $1,000 off a zip or a zip package. And all you have to do is basically show us that you are already a 3D printer, and you do that by taking a picture of your nameplate of your printer, send it to us. We'll validate that, and you'll be awarded with a coupon code for up to $1,000 off a new zip desktop printer. I think we're running it for the next 30 days. And this is a really great opportunity to jump in line, get a printer, and new printers that are ordered today are on a 2 to 4 week lead time. And that's all I have. And I just want to thank the speaker. Thanks, Rob. Thank you for taking us through that. It was an exhilarating talk, and I think there's a lot of interest on this topic area, and also a cool area to talk about.
Yeah.
And thank you to all the people who took time out of their day to attend. And we love to hear your comments and give us feedback on how we're doing. And we'll see you out there. Thanks, everybody. Bye-bye.
Thanks.